Good morning, everyone. Today we are going to do our last of the forces in motion PHET simulations. So we've already gone through and done a couple. We did net force, which was where you had the people pulling on the tug of war rope. And we did motion where there wasn't friction. It was on wheels, which for our purposes reduced the friction to essentially zero. And we did some things exploring that. Today we're going to now introduce friction. Now at the bottom here, you will see that there's a tab that says friction and a tab that says acceleration. They are pretty much exactly the same, except for that you have a bucket of water here instead of a trash can and a mystery box. And you can also select to show the acceleration. So when you do this, all the instructions are here. The first thing I want you to do is obviously watch this video. Then you're going to go to your sim and you're going to click on the last one, acceleration. If it needs to be, you're going to click here anytime you need to reset. And then each time you do that, you're going to need to go back through and click all the boxes here. You want to show all of those. And then for today, we're going to leave this friction slider alone. You can put more friction or less, and you can play with that on your own if you'd like. But to do our numbers here, we're going to leave it right where it is in the middle. Well, the first thing we're going to do is put on the box, and we're going to drag the water up there. So in my table here, I would go through and say box and water, and the mass of those together is 150 kilograms. So I fill that in right there. I'm going to do this first one for you so you can see how it works. It's very similar to the previous one we did. And then I want to know the minimum, the least applied force that I need to push to cause the object to begin moving. Now, in this case, there's friction, so it's going to push back on me, right? So in order to do this, I'm not going to use these arrows. I'm going to slowly slide. And you can see that as I apply more force to the right, the friction increases in resistance to it. It's trying to keep me from moving it. Okay? Now I want to know the minimum amount that I have to get get it moving. Notice the friction is equal, and at some point here, it'll begin, oh, there we go. It'll begin moving. And I got it there, if you look again, I got it there right around 375 newtons to get it moving. When I let go, you see the friction overwhelms and it comes to a stop. Well, that means I got it to be about here, about 375 newtons to the right. So I'm going to fill that in. Okay, I want to know the friction force that was acting on it once it started moving. So again, I'm going to slowly push. And again, you'll see the speed is 0 so far. The acceleration is 0, which you can see right here, the speed, right? And I'm going to take it up to about that 375. You'll see that the friction is equal. And then once it starts moving, the friction drops back down. It breaks some of that friction. Got it up to about 375. Now the friction force in opposition is about 281. So I'm going to put that here. That's 281 newtons to the left. The sum of the forces. Well, I can see the sum of the forces when I do that, so I get it up to about 375, or I can just subtract the 2, obviously, right? But 375-ish, right about there. It's around 94 newtons to the right. That's the net force when I subtract them. So fill that in. Then I want to know the force needed to keep it moving. Okay, well, I get it up to that speed. Let's get it up. When you do this, let's get it up to a fairly decent speed. So I'm going to push on it pretty hard now, get it going at a constant speed. We're going to speed up. You'll notice the acceleration is positive, 1.46. And then I'm going to try and bring it down here. Let's see, it's still speeding up because my acceleration is above 0. You can see it's going a little faster still, unless I bring it to here. Right? And so now the speed is holding constant, the acceleration is 0. It's not changing. Notice when I let go, by the way, the acceleration goes negative because it's slowing down. The friction is greater than any force applied, which is 0, and it goes down to 0 again eventually. All right, so the force needed to keep it moving once I got it going was still 281 here, right? Whoops, didn't want to do that. Go there. Okay, so once I got it moving, it stayed at about 281, and the net force was 0. That's why it was not accelerating. It still had a constant speed, and I had to keep applying force at that point. So you'll need to do that. You will then fill out the rest. You stack up whatever objects you want and fill out the rest of this table. And then on the next page, there will be some questions that you'll answer. So please make sure you check the second page. And when you're all done, please make sure you click Turn In. I've had a lot of students not click Turn In, and so I don't get it. And so you have a missing assignment, even though you did it. Make sure you turn it in. And that is all for this week, unless you are going to join me on the Zoom at 10 o'clock today, being Wednesday, the 1st of April, I guess. Okay, let me know if you have questions. Thank you very much, guys.